Welcome to The Explainer, where we break down big topics. Today, we're diving into a piece of life-saving tech that's been kinda stuck in the past and the amazing race to build its future, the artificial kidney. Okay, let's just start with a pretty striking comparison. Just think about the absolutely mind-blowing leaps in technology we've seen in our own lifetimes. I mean, we went from clunky, separate phones and cameras to a single device that puts a supercomputer and a connection to the entire globe right in our pocket. But here's the wild part. While all that consumer tech was racing forward at light speed, the machine that keeps millions of kidney patients alive, the dialysis machine, has pretty much stayed the same for 50 years. 50! And that is the big question, right? So today, we're going to dig into the huge problem this stagnation has created, the absolutely incredible vision for a solution, and the amazing entrepreneurial spirit that's finally dragging kidney care into the 21st century. So here's what we've got on tap. We're going to start with the problem, then check out the moonshot goal, break down the actual science, meet the innovators making it happen, and finally, see what the path to a new reality for patients really looks like. All right, let's get right into it and talk about the scale of this problem. Because this isn't just about old tech, it's about these staggering human and financial costs. First up, the money. In Europe, we're talking about 90,000 euros per patient every single year. This treatment is so expensive that it eats up 2 to 3% of the entire national healthcare budget in a lot of Western countries. That's huge. And behind that massive cost is an even more tragic reality. For 2/3 of the people on this planet who desperately need this treatment, it's just not an option. They live in places that just can't afford it, which means it's basically only available to the wealthy. And here's the thing. Even for the people who can get access, dialysis is not a cure, not even close. It only replaces about 10% of what a healthy kidney does. So what does that mean? It means patients are stuck in a clinic for hours, multiple times a week, with a life expectancy of just 5 to 10 years. It's a bridge, sure, but it's a terrifyingly short one. But a new vision is starting to take shape that could change all of this. And the goal here isn't just, a slightly better machine. No. This is a revolutionary leap. The vision is a biohybrid artificial kidney. Okay, just picture this. A device small enough to be implanted right inside your body that combines super advanced nanotechnology with actual living kidney cells. The idea is to create a synthetic organ that just works 24/7 like a real kidney, freeing patients from hospitals and machines for good. And listen, this isn't some sci-fi pipe dream. It's a real goal being chased by huge European research groups, backed by millions in funding. Projects like KidNew and Biohybrid Kidney XB are bringing together the sharpest minds in Europe to make this happen. So how on earth do you build a synthetic organ? I mean, the challenge is enormous, but scientists have been really smart about it, breaking it down into these manageable but totally revolutionary pieces. It's really a two-step process, and it's designed to mimic nature almost perfectly. Okay, step 1, the nanofilter. Think of it like a microscopic sieve made of silicon that just uses your body's own blood pressure to filter out all the junk. No pumps needed. It acts just like the kidney's natural filters, the glomeruli. Then comes step 2, the bioreactor. This part has living kidney cells that get to work on that filtered fluid, pulling all the good stuff back into the blood and actively pushing toxins out to create urine. It's mimicking the kidney's tubules. So when you look at them side by side like this, you can really see how closely this new tech is trying to copy our own biology. From filtering the blood to reabsorbing nutrients, the whole goal is to make a device that isn't just a machine, but a true, functioning replacement for a natural kidney. Now, a breakthrough like this doesn't just happen in some isolated lab. It's the result of this powerful collaborative ecosystem. And the driving force behind it is this spirit that can be summed up by the concept of chuangye. It's this awesome blend of pioneering entrepreneurship and just bold, creative innovation. I mean, just look at all the different players it takes to make this work. You've got the big consortia coordinating everything. Then you have these highly specialized startups building crucial little parts, deep research institutes doing the foundational science, and labs dedicated to testing. And tying it all together, the funders who make it possible. Every single piece of this machine is essential. And this is where that chuangye spirit really shines. You've got these focused, nimble startups tackling one critical piece of the puzzle. Like MiSep in Poland is developing the advanced membranes, while Optifluid in Estonia is creating optical sensors to monitor the device in real time. These are the specialist innovators.
And of course, they're backed up by the research powerhouses. Institutions like UMC Utrecht are figuring out how to grow kidney tubule cells from adult stem cells. I mean, this is the deep, fundamental science that provides the living parts for that bioreactor.
Okay, but where do all these different pieces come together to see if they actually work? That's the job of the enablers, places like the Artificial Kidney Innovation Test Lab. They provide the specialized gear where prototypes can be built and tested in conditions that mimic the real world. And powering this entire ecosystem are the vision funders. Organizations like the European Innovation Council and Health Holland are the ones providing the long-term cash needed for these kinds of moonshot projects. And this whole collaborative model is absolutely key because no single company could ever take on decades of risk and master all these different fields, from nanofabrication to cell biology to pull something like this off. So, how does this all come together to create a future we can actually see? Well, this isn't just some vague dream. There's a real path forward. And we can see a pretty concrete roadmap. The Kidno project, for instance, has a 48-month plan. It kicked off in 2023, they're developing the core membrane and cell units right now, and they're aiming to integrate everything into a working prototype by 2027. This makes the whole journey feel real and tangible. And that right there is the ultimate takeaway. The technology is absolutely incredible, but the goal is so profoundly human. It's about moving past just keeping patients alive and instead giving them their lives back, their freedom, their energy, their future. This whole incredible journey leaves us with a pretty deep question. As we start to cross this boundary from just treating diseases to actually engineering and integrating living organs into the body, we're not just challenging the limits of medicine, we're challenging our very understanding of what it even means to be human.